Polyatomic ions are ions that contain many atoms, but it's only one ion. They're usually negatively charged, but there are a few positives. We will only talk about one. That's the only one that I'm going to require that you know. The chart that you see here is going to help you remember what those polyatomic formulas are and what their names are, so what their endings are. Many of the endings that you'll see will end with ATE. If they end with ATE, that's what we're going to set up here on this chart. So the first thing you do is cross off O and F, and then these three right here, B, C, and N, they will all form an O3, so they'll have an O3 on the end when their ending is 8. These three as well, chlorine, bromine, iodine, they also form O3s when their ending is 8. So that's borate, carbonate, nitrate, chlorate, bromate, iodate. So that's how many oxygens they will have when they have the 8 ending. The rest of these here all have 4 O's. So usually rather than writing O4 next to each element, I usually just write a big O4 over that whole section. So I know all of those, when they end with ATE, they have 4 O's. Now to be ions, you have to have a charge as well. So borate has a -3 charge, carbonate has a -2, and nitrate has a -1. The rest of these down here on the bottom, these bottom 3 rows, are actually the same charges as your periodic table. So we've got -4, -3, -2, and -1 for everything, for the 3 rows that are above each of those. So there you have 15 polyatomic ions that all have the ending ATE. Sometimes you'll notice the ending is ITE or ITE. If the ending is ITE, you're going to take one less oxygen than is on this chart we just made. So borite would be BO2, still a -3. Phosphite would be PO3, and it would still be a -3. So you just take one oxygen away. Sometimes what you'll see is a prefix hypo, still with ite on the end. That means 2 less oxygen. Same charge. So hypochlorite would just be ClO, -1. Hyposulfite would be SO2, -2. Sometimes you'll see a prefix on the 8 ending as well. So you would see per and then 8 on the end. Per means you add 1. So the way I remember is per means plus. Right? So 1 more oxygen than is on your chart there, right? So the 8 is what's on the chart. There's a few that you just have to remember. The few that you have to remember are right here, the negative ones. That one positive one that I mentioned earlier, ammonium, is NH4, and it's a +1. So if we try to go through an example or two, let's say we have magnesium phosphate. We have magnesium phosphate. We know magnesium is a +2 because it's in group 2. Phosphate here, so it ends with 8, is what's on my chart. So PO4, that's phosphate, and that has a charge of -3. So I've got magnesium, I've got phosphate, and this works the same as our ionic compounds before. So I can cross the 2 here, and I can cross the 3 here. So Mg3, PO4, 2. But that looks like 42, so we put parentheses around the PO4. If I have something like sodium hypophosphite, I look up Na, sodium's a +1, hypophosphite. Here's phosphate. Hypophosphite is 2 less oxygen. So instead of 4 O's, I would have 2. So it would be PO2, and it's still a -3. So this has to stay the same, this has to stay the same. I can move the charge. So I have Na2PO2. Hopefully that helps you out a little bit. If you need anything else, please make sure you let me know.